To store the dataset into a pandas data frame, use the .data attribute. It's important that you store feature names as columns in the data frame. Use the head method to view the first 5 observations of the dataset. You can use the shape method to view the shape of the dataset. As you can see, it has 506 observations and 13 features. Similarly, you can view the shape of the target, which shows that there are 506 labels or responses. To view the target values, print it as shown here. Through this demo, you have learned how to load the built-in datasets of Scikit. In this demo, you'll see how to create and train a linear regression model, and to calculate the mean square error and variance of a given dataset. Start by importing the required libraries for Pandas and NumPy. Python's Sklearn has several built-in datasets. For this demonstration, I'm going to import a small census report of a region in Boston. To instantiate the dataset, create a variable as shown here. Use the .data attribute to store the dataset into a Pandas data frame. To store the features names as columns in the data frame, use the syntax shown here. The price of the houses in the Boston area is one of the columns of the data frame. Define it as the target or response attached to the dataset. Use the head method to view the first 5 observations. You can see that price is added to the dataset as the last column. The next step is to assign the attributes of the dataset to the x-axis. Similarly, assign the target values to the y-axis. To use Scikit-learn's linear regression model, import its class. Create an object, also called an estimator, to instantiate the class. Now that the model is created, fit the dataset, both features and target values, into the model object line reg. Use this syntax to print the intercept. Note that %.2f is used to round off decimal numbers to 2 decimal places. To print coefficients, use the syntax shown here. The format %d is used to print numerical or decimal variables. Use cross-validation to train the model. To do that, import the class validation class. Then, split the dataset into training and testing sets, as shown here. By default, the training and testing dataset split percentage is 75 to 25. Now fit the training dataset into the estimator or model object. Use the predict method to calculate the MSE or mean square error for the model. Use the score method to calculate the variance. The closer the value is to 1, the higher is the model's accuracy. In this demo, you learned how to use the linear regression model of Sklearn to calculate the MSE and variance of a dataset. Logistic regression algorithms are mainly used for categorical data. We use a set of input features to predict the probabilities of class membership. In simpler terms, this means that the algorithm predicts the class of each observation present in the dataset. The equation is the simplest logistic function used to perform logistic regression. To interpret the outputs of a logistic function, we must understand the difference between probability and odds. The odds of an event is the ratio of the probability of the event to its complement. One interesting observation here is that if you take the logarithm of odds, it becomes linear regression. So the data generalization switches from categorical to regression. Let's see how logistic regression works in Sklearn. Logistic regression, a Sklearn class, has to be instantiated by creating an object, also called an estimator. There can be two types of algorithms. First is OVR, or one versus rest. It's most suitable for binary problems. The second algorithm type is multi-nominal, which is a multi-class option. Multi-class specifies whether the algorithm is OVR, or binary, or multi-nominal. Penalty is used to specify the norm used in the penalization. The Newton CG and LBFGS solvers support only L2 penalties. Dual is implemented only for an L2 penalty. C is the inverse of regularization. Fit-intercept calculates the intercept. If the Boolean variable warm start is true, then the algorithm reuses the solution of the previous call. InJobs specifies the number of jobs in parallel computation. Random state is the seed or the random state instance. Liblinear is the algorithm to be used in the optimization problem. K-nearest neighbors, or KNN, is one of the simplest machine learning algorithms used for both classification and regression problem types. This algorithm uses the entire training dataset to create its model. It looks at the inputs or features of the training dataset to identify the